An aeroplane, one of the most important inventions in human history. It has completely changed the way people travel, communicate, and connect with different parts of the world. Before the invention of the aeroplane, long journeys across countries and oceans took weeks or even months and involved many dangers. Today, people can travel thousands of kilometers within a few hours in comfort and safety. The aeroplane has made the world feel smaller and has played a major role in the development of modern civilization. The idea of flying has fascinated humans since ancient times. Many early civilizations imagined humans flying like birds, and several myths and stories reflect this dream. One famous example is the Greek myth of Daedalus and Icarus, which shows humanity's desire to conquer the sky. During the Middle Ages, thinkers and inventors began studying flight more seriously. Leonardo da Vinci designed several flying machines and drew sketches that were far ahead of his time. However, due to a lack of proper materials and technology, these ideas could not be turned into working machines. The real progress in aviation occurred in the early 20th century. In 1903, Wilbur and Orville Wright achieved the first successful powered and controlled flight in the United States. Their aircraft flew for a short time, but it proved that sustained flight was possible. This historic achievement marked the beginning of the aviation age. After this success, scientists and engineers around the world began improving aircraft design and performance. The development of aeroplanes increased rapidly during the First and Second World Wars. During these wars, aeroplanes were used for observation, fighting, bombing, and transporting supplies. As a result, aircraft technology advanced quickly. Faster engines, stronger materials, better navigation systems, and improved aerodynamics were developed. The invention of jet engines during World War II brought a major change in aviation and led to the creation of faster and more powerful aircraft. After the wars, aeroplane technology was adapted for civilian use. Commercial aviation expanded, and airlines started offering regular passenger services. Jet airplanes made air travel quicker, safer, and more affordable for the general public. This growth helped connect countries and boosted international trade and tourism. Airports became important centers of economic activity, and aviation created employment opportunities for millions of people worldwide. An airplane is made up of several important parts that work together. The main body, called the fuselage, carries passengers, cargo, and essential equipment. The wings are the most important part, as they produce lift and allow the airplane to fly. The tail section helps maintain balance and control during flight. Engines provide the power needed to move the aircraft forward, while the landing gear supports it during takeoff, landing, and movement on the ground. Aeroplanes fly due to the interaction of four main forces. Lift allows the airplane to rise into the air, while weight pulls it toward the earth due to gravity. Thrust pushes the airplane forward and is produced by the engines. Drag is the resistance caused by air opposing the movement of the aircraft. For successful flight, lift must overcome weight, and thrust must overcome drag. There are different types of airplanes designed for different purposes. Passenger airplanes are used to transport people over short and long distances. Cargo airplanes carry goods and play a crucial role in global trade. Military airplanes are used for defense, surveillance, and transport. There are also small private airplanes used for training, sports, and personal travel, as well as special-purpose airplanes used for medical services, firefighting, and scientific research. Airplanes are extremely important in modern life. They provide the fastest means of transportation over long distances and help connect people from different cultures and countries. Aviation contributes greatly to economic growth by supporting tourism, trade, and international business. Airplanes are also essential during emergencies, as they are used to deliver relief materials and transport patients quickly. In addition, they play a vital role in national security and scientific research. Despite their many benefits, airplanes also have some disadvantages. Air travel can be expensive, and maintaining aircraft requires high costs. Aeroplanes contribute to air and noise pollution, especially near airports. They also depend heavily on weather conditions, and although accidents are rare, they can be severe. The environmental impact of fuel consumption is a growing concern in today's world. Aeroplanes affect the environment mainly through the emission of greenhouse gases, which contribute to climate change. Noise pollution caused by aircraft can disturb both humans and wildlife. To reduce these problems, scientists are developing fuel-efficient engines, sustainable aviation fuels, and electric or hybrid aeroplanes. These efforts aim to make air travel more environmentally friendly. The future of aeroplanes is full of possibilities. New technologies are being developed to create faster, safer, and cleaner aircraft. Supersonic aeroplanes may make long journeys even shorter, while electric and hydrogen-powered aircraft could reduce pollution. Automation and artificial intelligence may also change the way aeroplanes are operated. These advancements show that aviation will continue to evolve and improve. An aeroplane, also known as an airplane, is one of the most important inventions in the history of modern civilization. It is a powered flying vehicle with fixed wings that is designed to travel through the air using engines and aerodynamic principles. Aeroplanes have transformed the way humans move across the planet, shrinking distances, connecting continents, and enabling rapid transportation of people, goods, and ideas. From early experimental flying machines to today's advanced jet aircraft, the aeroplane represents human curiosity, scientific progress, and the desire to overcome natural limitations. The concept of flight fascinated humans long before aeroplanes became a reality. Ancient myths, legends, and drawings show that people dreamed of flying like birds. Early inventors studied the movement of wings and air currents, attempting to imitate nature. However, these early attempts were mostly unsuccessful due to limited scientific knowledge and lack of suitable materials and engines. It was not until the late 19th and early 20th centuries that technological advancements made controlled, powered flight possible. The modern aeroplane traces its origins to the work of pioneers such as the Wright brothers, Wilbur and Orville Wright. In 1903, they successfully achieved the first controlled, sustained, and powered flight of a heavier-than-air aircraft. This event marked the beginning of a new era in transportation. Their success was based on careful experimentation, understanding of aerodynamics, and the development of effective control systems. The Wright brothers' achievement proved that human flight was not only possible but could be improved and expanded. Following the first successful flight, aeroplane technology developed rapidly. During the early 20th century, aeroplanes were primarily used for experimentation, exploration, and military observation. World War I played a major role in accelerating aviation development, as nations invested heavily in improving aircraft speed, strength, and maneuverability. Aeroplanes evolved from simple wooden structures covered with fabric into more reliable machines capable of combat, reconnaissance, and communication. Between the two world wars, aeroplanes began to find civilian uses. Commercial aviation emerged as aircraft became safer, faster, and more comfortable. Airlines were established, airports were built, and air travel slowly became accessible to the public. The introduction of metal aircraft structures and more powerful engines significantly increased the range and reliability of aeroplanes. By the mid-20th century, flying had changed from a risky adventure into a practical means of transportation. World War II marked another major turning point in the history of aeroplanes. Aircraft technology advanced at an unprecedented pace during this period. Fighters, bombers, and transport planes were developed with greater speed, altitude capability, and payload capacity. After the war, many of these technological innovations were adapted for civilian use, leading to the rapid growth of commercial aviation in the post-war era. The invention of jet engines revolutionized aeroplanes and transformed global travel. Jet-powered aircraft could fly higher and faster than propeller-driven planes, drastically reducing travel time between distant regions. This development made international travel more common and affordable, encouraging cultural exchange, tourism, and global trade. Large passenger jets enabled thousands of people to travel across continents every day, reshaping economies and societies. Today, aeroplanes are an essential part of global infrastructure. They are used for passenger transport, cargo delivery, emergency services, scientific research, and military operations. Modern aeroplanes are highly complex machines that combine advanced materials, digital systems, and precise engineering. Despite their sophistication, the basic principles of flight remain rooted in the same aerodynamic concepts discovered by early pioneers. The history of the aeroplane demonstrates how human innovation evolves through experimentation, failure, and improvement. From fragile early flying machines to modern aircraft capable of crossing the globe in hours, aeroplanes reflect the continuous pursuit of efficiency, safety, and performance. Understanding their development helps explain why aeroplanes have become one of the most influential technologies of the modern world. The ability of an aeroplane to fly is based on a combination of physical forces and aerodynamic principles. When an aeroplane moves through the air, it interacts with the surrounding air in a way that produces lift, allowing it to rise above the ground. The four fundamental forces acting on an aeroplane in flight are lift, weight, thrust, and drag. Lift is the upward force generated by the wings, weight is the force of gravity pulling the aircraft downward, thrust is the forward force produced by the engines, and drag is the resistance caused by air opposing the motion of the aeroplane. Lift is created primarily by the shape and angle of the wings. Aeroplane wings are designed with a curved upper surface and a flatter lower surface, a shape known as an airfoil. As the aeroplane moves forward, air flows faster over the curved upper surface than under the lower surface. This difference in airspeed results in lower pressure above the wing and higher pressure below it, producing an upward force. In addition to wing shape, the angle at which the wing meets the air, called the angle of attack, plays a crucial role in generating lift. If the angle is too low, insufficient lift is produced, and if it is too high, the wing may stall. Thrust is the force that propels an aeroplane forward through the air. In early aeroplanes, thrust was produced by propellers driven by piston engines. Modern aircraft commonly use jet engines, which generate thrust by expelling high-speed exhaust gases backward, pushing the aeroplane forward according to Newton's third law of motion. The type of engine used depends on the aircraft's purpose, speed requirements, and fuel efficiency considerations. Regardless of the engine type, sufficient thrust is necessary to overcome drag and maintain forward motion. Drag is the aerodynamic resistance experienced by an aeroplane as it moves through the air. It is caused by friction between the aircraft's surface and the air, as well as by changes in airflow around the wings and body. Engineers work to reduce drag by designing smooth surfaces, streamlined shapes, and efficient wing structures. Minimizing drag improves fuel efficiency and allows aeroplanes to achieve higher speeds with less energy consumption. The structure of an aeroplane is carefully designed to withstand the forces experienced during flight. The fuselage is the main body of the aircraft and houses the cockpit, passengers, cargo, and essential systems. The wings are attached to the fuselage and are responsible for generating lift. The tail section, also known as the empennage, provides stability and control. It includes horizontal and vertical stabilizers that help maintain balance and direction during flight. Control of an aeroplane is achieved through movable surfaces on the wings and tail. Ailerons, located on the wings, control rolling motion and allow the aircraft to turn left or right. Elevators, attached to the horizontal stabilizer, control pitch and enable the aeroplane to climb or descend. The rudder, mounted on the vertical stabilizer, controls yaw and helps maintain directional stability. By coordinating these control surfaces, pilots can maneuver the aircraft smoothly and safely. Modern aeroplanes rely heavily on advanced technology to enhance safety and performance. Navigation systems, flight computers, and automated controls assist pilots in managing complex flight operations. Instruments provide real-time information about altitude, speed, direction, and engine performance. In many commercial aircraft, autopilot systems can control large portions of the flight, reducing pilot workload and improving precision. The working of an aeroplane is a result of the careful balance between aerodynamic forces, mechanical systems, and human control. Every flight involves continuous adjustments to maintain stability, efficiency, and safety. Understanding how aeroplanes work not only highlights the complexity of aviation but also emphasizes the scientific principles that make human flight possible. Aeroplanes are designed in many different forms, each suited to specific purposes and operating conditions. The wide variety of aeroplane types reflects the diverse needs of human society, ranging from transportation and commerce to defense and scientific research. Differences in size, engine type, speed, range, and structural design allow aeroplanes to perform specialized tasks efficiently and safely. One of the most common types of aeroplanes is the commercial passenger aircraft. These aeroplanes are designed to carry people over short, medium, and long distances. Passenger aeroplanes vary in size from small regional planes serving domestic routes to large wide-body jets capable of transporting hundreds of passengers across continents. Comfort, safety, and fuel efficiency are key considerations in their design. These aeroplanes play a vital role in connecting cities and countries, making global travel faster and more accessible. Cargo aeroplanes are specifically designed to transport goods rather than passengers. They are equipped with large storage areas, reinforced floors, and wide doors to accommodate heavy and oversized cargo. Cargo aircraft are essential to global trade, enabling rapid delivery of goods such as food, medical supplies, industrial equipment, and consumer products. Their ability to operate on tight schedules makes them especially valuable for transporting perishable or urgent items. Military airplanes represent another important category. These airplanes are designed for defense, combat, surveillance, and strategic operations. Fighter jets are built for speed, agility, and air combat, while bomber aircraft are designed to carry heavy payloads over long distances. Transport and reconnaissance aircraft support military operations by moving troops, equipment, and gathering intelligence. Military airplanes often incorporate advanced technology, including stealth features and sophisticated weapon systems. Training airplanes are used to educate and prepare pilots for more complex aircraft. These airplanes are designed to be stable, easy to control, and forgiving of pilot errors. Flight training is a critical part of aviation safety, and training airplanes allow students to develop essential skills such as takeoff, landing, navigation, and emergency handling. Many commercial and military pilots begin their careers flying these simpler aircraft. Agricultural airplanes serve specialized roles in farming and land management. These airplanes are used for crop spraying, seed planting, and pest control. Their ability to fly at low altitudes and cover large areas efficiently makes them valuable tools in modern agriculture. By improving productivity and reducing manual labor, agricultural airplanes contribute to food security and economic growth in rural areas. Airplanes are also widely used in emergency and humanitarian services. Medical evacuation aircraft transport injured or critically ill patients to hospitals quickly, often saving lives. Firefighting airplanes drop water or fire retardants over large forest fires, helping to control and reduce damage. Disaster relief aircraft deliver food, supplies, and rescue teams to areas affected by natural calamities where ground transportation may be unavailable. Scientific and research airplanes are used to study the atmosphere, climate, and Earth's surface. These airplanes are equipped with specialized instruments to collect data on weather patterns, pollution levels, and environmental changes. By flying at high altitudes or over remote regions, research airplanes provide valuable information that supports scientific discovery and environmental protection. Private and recreational airplanes cater to individuals and organizations seeking personal or leisure flying experiences. These airplanes are generally smaller and less complex than commercial aircraft. They are used for personal travel, aerial photography, tourism, and sports aviation. Recreational flying also plays a role in promoting aviation education and innovation. The wide range of airplane types highlights the versatility of this technology. From transporting millions of passengers each day to supporting agriculture, defense, science, and emergency response, aeroplanes serve countless functions in modern society. Their adaptability ensures that aviation remains a vital and evolving part of human activity. Aeroplanes have had a profound impact on society by transforming how people interact, communicate, and experience the world. Before the advent of air travel, long-distance journeys required weeks or even months. Aeroplanes dramatically reduced travel time, allowing people to cross countries and continents within hours. This change has brought societies closer together, encouraging personal connections, international cooperation, and global understanding. One of the most significant social impacts of aeroplanes is their role in connecting families and communities separated by vast distances. People can now visit relatives, attend important events, or relocate for education and employment with relative ease. This mobility has influenced migration patterns and contributed to the creation of multicultural societies. Air travel has also expanded access to education and healthcare by enabling individuals to travel to institutions and facilities that may not be available locally. Economically, aeroplanes play a crucial role in global development and trade. The aviation industry generates millions of jobs worldwide, including pilots, engineers, cabin crew, air traffic controllers, and airport staff. Beyond direct employment, aviation supports tourism, manufacturing, logistics, and service industries. Airports often become centers of economic activity, attracting businesses and investment to surrounding regions. International trade has been greatly enhanced by the use of aeroplanes. Air transport allows high-value and time-sensitive goods such as electronics, pharmaceuticals, and fresh produce to reach markets quickly. This efficiency supports global supply chains and enables businesses to operate on an international scale. Developing countries, in particular, benefit from air connectivity as it provides access to global markets and encourages foreign investment. Tourism is another area where aeroplanes have had a major influence. Affordable and efficient air travel has made it possible for millions of people to explore different countries and cultures. Tourism contributes significantly to national economies by generating revenue, creating jobs, and promoting cultural exchange. Destinations that were once isolated or difficult to reach have become popular tourist centers due to improved air connectivity. Aeroplanes have also played a role in shaping modern culture. The ease of international travel has facilitated the exchange of ideas, art, music, and traditions across borders. Global events, conferences, and cultural festivals depend heavily on air travel to bring participants together. This exchange has contributed to a more interconnected and interdependent world, where cultural influences spread rapidly. In times of crisis, aeroplanes provide critical support to societies. During natural disasters, conflicts, or health emergencies, aircraft deliver humanitarian aid, medical supplies, and rescue teams. The ability to respond quickly can reduce suffering and save lives. Aeroplanes also support international peacekeeping efforts and diplomatic missions by enabling rapid deployment and communication. Despite their many benefits, aeroplanes have also introduced challenges. Noise pollution near airports can affect the quality of life for nearby communities. Economic benefits are sometimes unevenly distributed, with major cities gaining more advantages than rural areas. These challenges highlight the need for responsible planning and sustainable development in aviation. Overall, the social, economic, and cultural impacts of aeroplanes are far-reaching and transformative. By enabling mobility, supporting economies, and fostering global connections, aeroplanes have reshaped human society in ways that continue to influence daily life and international relations. While aeroplanes provide immense benefits to society, they also have significant environmental impacts that cannot be ignored. One of the most discussed issues related to aviation is its contribution to air pollution and climate change. Aeroplanes burn large quantities of fossil fuels, releasing carbon dioxide and other greenhouse gases into the atmosphere. These emissions contribute to global warming and have long-term effects on Earth's climate system. In addition to carbon emissions, Aeroplanes produce nitrogen oxides and water vapor at high altitudes, which can intensify their impact on the atmosphere. The formation of contrails and cirrus clouds can trap heat and further contribute to climate change. As air traffic continues to grow worldwide, the cumulative effect of these emissions has become a major concern for environmental scientists and policymakers. Noise pollution is another environmental issue associated with aeroplanes. Communities living near airports often experience high levels of noise from takeoffs and landings. Prolonged exposure to aircraft noise can affect human health, leading to stress, sleep disturbances, and reduced quality of life. Wildlife can also be disturbed by noise, especially in areas close to natural habitats and protected ecosystems. Aeroplane operations also affect land use and natural environments. The construction and expansion of airports require large areas of land, which can lead to habitat destruction and displacement of local communities. Increased air traffic may also contribute to congestion and pollution around airport regions, affecting both urban and rural landscapes. In response to these challenges, the aviation industry has been working to reduce its environmental footprint. Aircraft manufacturers are developing more fuel-efficient engines and lightweight materials to reduce fuel consumption. Modern aeroplanes are designed to produce fewer emissions and less noise than older models. Improved aerodynamics and advanced navigation systems help optimize flight paths and reduce unnecessary fuel use. Alternative fuels and new technologies offer promising solutions for sustainable aviation. The use of sustainable aviation fuels derived from renewable sources can significantly reduce carbon emissions compared to traditional jet fuel. Electric and hybrid aircraft are also being researched, particularly for short-distance flights. While these technologies are still in development, they represent important steps toward a cleaner aviation future. Governments and international organizations play a vital role in promoting environmental responsibility in aviation. Regulations, emission targets, and international agreements encourage airlines to adopt sustainable practices. Passengers are also becoming more aware of the environmental impact of flying, leading to increased demand for greener travel options. Balancing the benefits of aeroplanes with environmental protection is one of the greatest challenges facing the aviation industry today. Sustainable solutions require cooperation between engineers, policymakers, airlines, and travelers. By investing in innovation and responsible practices, it is possible to reduce environmental harm while preserving the essential role of aeroplanes in global connectivity. Aeroplanes have long been a critical component of military strategy and national defense. Since their first use in World War I, military aviation has transformed the nature of warfare. Early aircraft were primarily used for reconnaissance, but they quickly evolved to perform combat missions, including bombing, air superiority, and troop transport. Modern military aircraft are highly specialized and technologically advanced, ranging from supersonic fighter jets to stealth bombers and unmanned drones. Their capabilities provide strategic advantages, enabling nations to project power, maintain security, and conduct surveillance on a global scale. The technological advancements in aeroplanes over the past century have been extraordinary. From basic wood and fabric structures to sophisticated aircraft made of composite materials, modern aeroplanes incorporate cutting-edge engineering, avionics, and digital systems. Jet engines revolutionized speed and efficiency, while fly-by-wire systems allow precise control of aircraft using computerized signals. Innovations in materials, aerodynamics, and fuel efficiency continue to make aeroplanes faster, safer, and more environmentally responsible. Satellite-based navigation and autopilot systems have made long-haul flights safer and more predictable than ever before. The future of aeroplanes promises even greater transformations. Researchers and engineers are exploring electric and hybrid propulsion systems, which could reduce dependence on fossil fuels and lower emissions. Supersonic and hypersonic passenger planes may drastically cut travel times, while autonomous flight technology could change the role of pilots and air traffic management. Urban air mobility, including flying taxis and compact electric aircraft, may soon reshape city transportation and reduce congestion on roads. Innovations in design, materials, and artificial intelligence are likely to make air travel safer, faster, and more sustainable in the coming decades. Aeroplanes have not only revolutionized transportation but also shaped human civilization in profound ways. They connect people, cultures, and economies across vast distances, enabling global commerce, tourism, and diplomacy. They support scientific research, emergency response, and humanitarian aid, while also advancing military defense and national security. At the same time, they pose environmental challenges, necessitating responsible innovation and sustainable practices. The story of the aeroplane is a story of human ingenuity, resilience, and ambition, a continuous effort to overcome natural limits and explore new horizons. In conclusion, the aeroplane is one of the most transformative inventions in human history. Its development, from the first powered flights to today's advanced aircraft, demonstrates the power of science, technology, and human imagination. Aeroplanes have reshaped society, economies, and culture, while also presenting challenges that require careful attention and innovation. As aviation continues to evolve, it will remain an essential part of human life, connecting the world in ways that were once unimaginable. The aeroplane is not merely a machine, it is a symbol of human progress, a testament to the desire to explore, and a cornerstone of the modern globalized world. The aeroplane is one of the greatest achievements of human innovation. It has transformed transportation, strengthened global connections, and supported economic and scientific progress. Although it faces challenges such as environmental impact, continuous technological development promises a better and more sustainable future. The aeroplane remains a powerful symbol of humanity's determination to explore, innovate, and reach new heights. Thank you for watching this video.